So here it is told that a uniform chain of length 3 meter and mass 3 kg overhangs a smooth table. Uniform chain, it is of length 3 m- meter and mass 3 kg. Mass is 3 kg. Length is 3 meters. So it means lambda, which is mass per unit length, that will be 1 kg per meter. Then it is told overhangs a smooth table with 2 meter lying on the table. So 2 meter is on the table and 1 meter is hanging from the table. If K is the kinetic energy of the chain in joule, as it completely slips off the table, then the value of K is. So here, we can say that kinetic energy that it will gain when it will completely strip off, that will be equal to the work done by the gravity. Since we know work done by all forces equal to change in kinetic energy. So here only gravity is doing the work. Since the table is smooth, there is no friction here. So now, therefore, work done by gravity, that will be equal to so 3 meter, 1 meter. So here is, let's say here is the ground, 3 meter. So simply, or we can do the gain in kinetic energy equal to loss in potential energy, loss in gravitational potential energy. So it means kinetic energy final minus kinetic energy initially it was 0 only. It will be equal to loss in gravitational potential energy, which is initial potential energy minus final potential energy. Now kinetic energy is K, and that will be equal to initial potential energy. So initially this mass is 1 kg, it was here. So it was its height, the height of the center of mass was at 3 plus half, that is 3.5 meters, and the center of mass of this was initially here at a height of 4 meters. So suppose we take this is 3, or we can take it as h also. Let this height be h, let this height be h. So initially the center of mass of this part, which was hanging from the table, that was h plus half meters, and this was h plus 1 meter. And when it will completely fall, from the table, when the chain will completely fall from the table, then Uh, this entire height was h plus 1. So the center of mass will be at a height of, so this is 3 meters. So this will be 3 by 2 meter. And this entire height is obviously h plus 1. So this will be h plus 1 minus 3 by 2 meters. H plus 1 minus 3 by 2 meters, which means it is h minus half meter. H minus half meter. So initial potential energy, it will be mg into h was h plus half, plus it was m, this part mass is 2 kg, since this length is 2 meter, mass of this part is 2 kg only, since it is also told that it is a uniform chain, so mass is proportional to the length. It means m, we can tell it is lambda times L, where lambda is the linear mass density, linear mass density. So mgh plus this part will be mg into h plus 1 minus the final potential energy, which will be this mass is 3 kg, mg into h will be h plus h minus half. So therefore we can say this k, the final kinetic energy of the chain when it slips off the table, then this will be this gh plus g by 2 plus 2gh plus 2g minus 3gh, then minus minus is plus, plus 3g by 2. So 3gh and 3gh, this will cancel out. So k will be equal to g by 2, that is 5, since g is 10, 2g, that is 20, plus 3 by 2 into g, that is 10, 2 5s are 10, 5 3s are 15. 15 plus 5 is 20, 20 plus 20 is 40. So k equal to 40 joule. So 40 joule is the answer. Then here it is told that a block slides down from the top of a hemisphere of radius 3 meter as shown in the figure. The height h at which the block will lose contact with the surface of the sphere is. The height h at which the block will lose contact with the surface of the sphere is. Yeah. So the block will slide down. Um, so here we can see this is angle theta, they are saying. So when the block will reach here, assume there is no friction between block and the hemisphere. So there is no friction. So here mg will act. Mg, radius is 3 meter. So this height will be, this height is h that they are saying. So it will, h will be equal to r cos theta, obviously. So mg will act, and here normal reaction will act. and it will attain, here it will attain a velocity v. Here u was 0 only, u was nearly 0. Okay. This radius is r. Okay, so it will fall through a height of r minus h. So it means there is a loss in gravitational potential energy, so there will be a gain in kinetic energy for the block. So I can say loss in gravitational potential energy, that is equal to gain in kinetic energy, since there is no frictional force. So therefore loss in potential energy means it is initial potential energy minus final potential energy equal to gain in kinetic energy, which means final kinetic energy minus initial kinetic energy. Now initial potential energy, that is mg r mgr minus final potential energy, which is mgh, and that is equal to final kinetic energy, which is half mv square, and initial kinetic energy, which is half mu square, but u is 0, so this will be 0 only. So the height at which it will lose contact, it is losing contact means the normal reaction should be 0. If the normal reaction exerted is 0, then only it will lose contact. Only it loses contact. So here we can see that the net force towards center will be equal to mass into centripetal acceleration. The net force towards center, that is equal to the centripetal force. So the net force towards center, I can say this is mg, then this will be mg cos theta. This way is mg cos theta. This way it will be mg sin theta. So I can say this will be net force, which is mg cos theta minus n, that is equal to mv square by r. So n will be 0. There it will lose contact. So m will cancel. So v square equal to rg cos theta. V square equal to rg cos theta. Now this height we have to find out. So now therefore mgr minus mgh, that is equal to half mv square of mv square. V square is rg cos theta. Now r cos theta we told that is equal to the height h. So therefore we can say mgr minus mgh, that is equal to m by 2 into gh. Okay, by 2 gh. M by 2 gh. So m by 2 gh plus mgh, that is 3 by 2 mgh, since half plus 1 is 3 by 2. 3 by 2 mgh equal to mgr. So mg will get cancelled. So h will be equal to 2r by 3. So at 2r by 3 it will lose contact. So r is told it is 3 meters. So height will be 2 by 3 into 3, that is 2 meters. So at 2 meters height it will lose contact. So 2 is the answer. And here it is told a force F, which is 5y plus 20 j cap, acts on a particle. The work done by this force when the particle is moved from y equal to 0 to y equal to 10 meter is dash joule. So force is acting along y axis. So, and it is a variable force. So therefore this should be in the vector form. So we know that so the work done, that will be equal to integral f dy, since it is acting along the y-axis. So it means it will be integral 5y plus 20 dy, and y is going from 0 to 10. So this will be 5 into integral y dy plus 20 into integral dy from 0 to 10. From 0 to 10. This will be 5 into y square by 2, 0 to 10 plus 20 into y from 0 to 10. So this is 5 by 2 into 10 square plus 20 into 10. So this will be 5 by 2 into 100 plus 200. 2 5 is 10. Okay. So 5 is 25, 250 plus 200. So that is equal to 450. So 450 joule. 450 joule is the work done by this force. Then here it is told in a spring gun having spring constant 10, spring constant 100 Newton per meter, a small ball B of mass 100 gram is put in its barrel as shown in figure by compressing the spring through 0.05 meters. Then there should be a box placed at a distance d on the ground so that the ball falls in it. The ball falls in it. If the ball leaves the gun horizontally at a height of 2 meter above the ground, the value of d is. So here one box should be placed. One box should be placed here, so on the ground, so that the ball can come here and it can fall on the box. The spring is compressed, so then so it is placed at uh, uh, distance d on the ground. So this distance d we have to find out. So it is compressed. Okay. So d is nothing but the horizontal range of this projectile. So it is a here projectile motion is happening. So d is the range. So d I can say it will be equal to u into t. The t is the time of flight. So I can say d will be equal to u into t, where u is the initial velocity uh, of this small ball b. So now the time of flight we have to find. So time of flight will be equal to uh, obviously half gt square equal to the height h. Height h is 2 meter above the ground. So t will be equal to obviously root over 2h by g, which is root over 2 into 2 by 10. For the 10, so root over 2 by 5 seconds. So u that we have to find. So here the kinetic energy gained half mu square, that will be equal to the loss in spring potential energy, equal to loss in spring potential energy, which is equal to half kx square. Initially the spring was compressed, so initially the potential energy was half kx square. Of kx square, where k is the spring constant and x is the amount of compression in the spring. So half we can cancel. So then u square I can say it is k by m into x square. means u is equal to root over k by m into x. So therefore u will be equal to root over k is 100 by m mass is 100 grams, so it means it is 0.1 kg. So 0.1 into x is 0.05. So this will be 1 by 10, so it is root over 1000 into 0.05. So it is like 10 root 10 into 0.05. So I can say it is 0.5 into root 10. 0.5 into root 10 meter per second. So therefore the r- distance d at which the box should be placed on the ground, the distance d the distance d at which the box should be placed on the ground, that will be t will be equal to u into t. So u is half into root 10 into 2 by root over 2 by 5 seconds. So this will be 1 by 2 into root over 2 into 10 by 5. So this is 5 fours are 20. So half into 2, that is 1 meter. So 1 meter is the distance d. So 1 is the answer. And it is told a ball of mass 4 kg ball, which is there. Its mass is 4 kg. It is moving with a velocity u, that is 10 meter per second. It collides with a spring. It collides with a spring having length 8 meters and force constant, that is 100 Newton per meter. The length of the compressed spring is x meter. The length of the compressed spring, okay, length of the compressed spring, that is x. The value of x to the nearest integer is, to the x we have to find out. Spring of length 8. Force constant means it is the spring constant k. So therefore here we can say that the loss in kinetic energy will be equal to gain in spring potential energy. Gain in spring potential energy. So loss in kinetic energy, that will be the final kinetic so the initial kinetic energy, which is half mu square, and final kinetic energy is 0, and gain in spring potential energy means final potential energy minus initial potential energy. So this will be 0 only, since why initially the spring was not in the compressed state, and finally it is getting compressed by a length 8 minus x. So 8 minus x is the amount of compression, in the spring. So this x you have to find out. Okay, so half mu square, that is equal to half k x square, where x here the compression is 8 minus x. So I will write 8 minus x whole square. Half and half will get cancelled. So m is 4 and u is 10. So 10 square by k is 100. That is equal to 8 minus x whole square. So therefore 400, so 100 will cancel. So 8 minus x whole square, that is equal to 4. So 8 minus x, that is equal to plus or minus 2. So here it means x can be 8 minus plus 2. 8 plus or minus 2. So it means x can be 6 or it can be 10, but x cannot be 10, since why the length of the spring is in its natural state. The natural length of the spring is only 8, so it can't be X cannot be more than 8. X should be less than 8 and more than 0. In this range only the X value should come. So X should be 6. That means X, the value of X is 6. Then here it is told as shown in the figure, a particle of mass 10 kg is placed at a point A. When the particle is slightly displaced to its right, it starts moving and reaches the point B. It starts moving and reaches the point B. The speed of the particle at B is x meter per second. So here the speed, here it will have a speed x meter per second. So this x we have to find out. So here we can say loss in gravitational potential energy, loss in gravitational potential energy equal to the gain in kinetic energy. So here the initial velocity will be 0 only. So loss in gravitational potential energy means initial potential energy minus final potential energy, which is equal to final kinetic energy minus initial kinetic energy. So initial potential energy, it was mgh, where h was 10. It's mg into a initial height minus mg into final height. That is equal to final kinetic energy, which is half mv square minus half mu square. But u is 0, so this will be 0 only. So m also we can cancel out. So v square will be equal to 2g into h initial minus h final. So v square, that is equal to v is only x here. V is equal to x, the speed of the particle, the speed of the particle at the point B, that is x only. So v will be x. So I can write x square, that is equal to 2g into initial height, that is 10, and final height, that is 5. So therefore x square, that is equal to 2 into g is 10 into 5. 5 to the 10. So x will be equal to 10. So 10 meter per second is the speed at the point B. So 10 is the answer. Then here it is told the potential energy U of a diatomic molecule is a function dependent on R, where R is the interatomic distance. So it means when a diatomic molecule is formed, then their interatomic distance is R. R is the interatomic separation or interatomic distance. So you can say the potential energy U, that is alpha by R power 10 minus beta by R power 5 minus 3. Alpha by R power 10 minus beta by R power 5 minus 3, where alpha and beta are positive constants. The equilibrium distance in between the two atoms will be 2 alpha by beta power a by b. 2 alpha by beta power a by b, where a will be how much? The equilibrium di distance we have to find. So at equilibrium, as you know, at equilibrium, it means the net force acting, that should be 0. And we know that force that is equal to minus du by dr. So that should be 0. So then that value of R we have to find at which the force is 0. So now therefore we have to find du by dr, that should be 0 only. Means that at r equal to r equilibrium, that we have to find out. At r equal to r equilibrium, du by dr, that will be 0 only. So that r equilibrium we have to find out. So now du by dr will be how much? That is uh, minus 10 nx power n minus 1. No, d by dx of x power n, that is equal to nx power n minus 1. So this is r power minus 10. This is minus 10 alpha by r power 11, then plus 5 beta by r power 6 plus 0, since 3 is a constant. So that should be equal to 0. So at r equilibrium only this will happen. So now therefore I can say at 5 beta by r equilibrium power 6, that will be equal to 10 alpha by r equilibrium power 11. Therefore 5 2s are 10. So therefore I can say r equilibrium power 11 minus 6, that is equal to 2 alpha by beta. So therefore r equilibrium I can say that is 2 alpha by beta power 1 by 5. Since this is r equilibrium power 5, actually this is there is 2 alpha by beta. So r equilibrium is 2 alpha by beta power 1 by 5. So therefore a is equal to 1 and b is equal to 5. A is equal to 1. So the value of a will be 1 and the value of b will be 5. So hope all of you understood the solutions of all these questions based on the previous year JEE Mains exam. Still any doubts, if you have, please write that in the comments section. We shall obviously clarify them in the subsequent videos. And please install our Sapience education application also, where we shall upload some important questions which shall be helpful for your exam. So thank you everyone. Bye.